Hello, my name is David and welcome to David Computes. On this part 2 video on Excel study of daily percentage for gain-loss, we'll be continuing our work from the previous video. We have decided that we're going to make a count of the frequencies for gains and losses for the SPX, which is the data set you can see here on the left side. And we'll be using an histogram to get a better view of the counts for each one of the percentage. So just for purposes of this video, I'll be using a 0.2 bin. So we've seen from our calculation that the maximum value that we've seen, a maximum gain on a daily basis, was 5.49%. The minimum was minus 571. So we know those are our extremes, and therefore we'll be creating bins taking those values into consideration. Let's use a bin of 0.2. So to start with, let's say we have 570. So that's our minimum, and if we put an increment of 0.2, and carry on like that, all the way to 5.49. So it's quite a very granular histogram. If we wanted, we can do something slightly simpler, but for these purposes, let's do a rather complex one, and then the same principles apply for anything else. So we have our bins here, and now we're going to calculate the number of counts for each one of these. So as an example, how many days did we see the SPX losing between 5.7 and 5.5, and then of course from minus 5.5 to 5.3. So let's do this and see what does the data tell us. What can we glean from this observation? So to start this, we're going to be using data analysis, which is histogram. Data tab, and then you should see a section called data analysis, and in that data analysis you'll find the histogram. If you don't see it, as you can see for instance in this case, you can easily add it. So if you go here and you go to the add-ins, and you'll find the analysis tool pack here. Okay, so you can add that. We only need the first one. We don't need to do anything else. And there you go. You get to see the data analysis tab that is now visible. So let's click here on the data analysis, and you get several studies. In this case, we're interested in the histogram. So you click histogram, you get another pop-up. On this pop-up, we're going to introduce our data, so the input range. So it's all our close opens all the way to that row, so the entire data set. And then we're going to put our bin range, which, as we covered, starts on the minimum value to the maximum value with an increment of 0.2. And then we're going to choose a cell to have our put. We can choose a new spreadsheet, but in this case we're just going to put a new range here, and let's put it here. Okay, press OK, and there you go. We have our histogram here. So what does the histogram tell us? Well, it tells us that between 5.7 and 5.5 decrease, there was only one count. And it tells us that between 5.5 and 5.3, there was no counts, as you can see here. You can see that the bulk of the counts are around the 0 value, which if you think about it makes sense, as most of the days you generally see either a small gain or a small loss, and it matches of course with our calculated average of 0.02, and of course the median of 0.05. median being the most observed value, so the most, the highest frequency count, which we can see actually here in more detail is between 0.3 and 0.5 with 262 counts. Okay, so now we've done this bit of work. What can we ascertain from this? Let's get a chart of these distributions to help us visualize the data and help us get a better idea of what we're looking at. Let's add a bit more space here. So let's chart this data. Let's chart the data we just collected. Let's do a chart here. And let's see, let's choose, let's just choose this column here. We're not choosing the histogram because we're not interested in that, but let's choose this. So let's get this, let's get a bit more, this chart. Extend the area so we get a better visualization. Okay, so this chart will help us actually visualize the data we've compiled. So what we can immediately see is that the distribution is actually fairly normal. There's no big outliers. We see that most of the days have a gain of between, a few decimals of percent or a loss. So most of the bulk of the days will have a gain here. We can also think about this data in terms of how many days fall within one standard deviation. So for this data set we have 1,837 days. So for one standard deviation, which is approximately 68%, how many days would that be? So that's 1,249 days, rounding down, will fall for one standard deviation, so or one sigma. So how can we quickly check what is the interval within this one standard deviation? So if we highlight the highest count, which is 326 for 0.1% bucket, 0.1 to 0.3, we have the highest count here. So let's highlight that. Let's put a background here. Let's get something flashy. And then the way we do it is you look up and down and you see what's the next big number. So in this case will be 262, and then starting from that or above, which is the biggest number. So 186 or 237, so 237. And what's the next one? Is it 186 or 107? Clearly 186. And you progress like this until you get a sum of days that approximates 1,249. So let's say, for instance, if we consider this, what is this sum? So we'll be very, very close. So what we can see here is, so if let's paint this again, some flashy colors, hopefully not too flashy. So we see that this interval represents to one standard deviation. So between having a down day of 0.3 and gaining 0.5, that is one standard deviation. So what does this mean? It means that 68% of your days for this data set, it means that the Standard & Poor's will between lose 0.3 and gain 0.5. So 68% of your days will be within this range. If you want to do a bit more extreme, let's say if we calculate for 2 standard deviations, which is roughly 95%, this will give us 1,745 days. So the vast majority of days will be within 2 standard deviations. But the conclusion that one can take from here is that really anything that starts to be again bigger than 0.7 or loss bigger than bigger than 0.5 starts to become very, very unusual. So it starts to become a very low probability event. Although having said that, we should not take too many conclusions about this, but it gives you a first glimpse of what statistics you can remove from your time series. For this video and the previous one, we've used Standard & Poor's, so we used the daily session for the US markets for the Standard & Poor's, which in UK time opens it to 14:30 and then closes at 21. Of course, this could have been done with any other time series, FX, equity, some stock time series, could be done with futures data. You know, you could have done this with the E-mini futures. You can do this study with any time series that you want. For this purpose, I just thought it would be straightforward to use this. I'll end this video for now. It's getting long, and I'll keep it short. If you like this video, please leave a like, and if you like to receive a notification when new videos are published, don't forget to subscribe. Thank you very much for watching, and hope you find this interesting and inspiring.